LemelsonMIT Program. Thanks a lot for your interest in the webinar this evening. Welcome you all. It's very nice to see a lot of new friends and also old friends coming back to our webinar. Yeah. Probably a lot of you have known that this is our last Invention Education webinar this academic year. We have been offering this kind of free webinars once every 2 weeks since last October. The topics we have discussed in the webinars include minds-on and hands-on skills that we think are essential to invention education. This week, we'll talk about one of the hands-on skills that is about 3D printing and CAD tools. All of our previous webinars have been recorded. You can find the recorded webinars and the slides on our website. And also after this webinar, we will send out the email about how you can access this recording on also the slides. So please keep an eye on that one. For today's webinar, you can see that we have set up a chat window for you to post your questions. At the end of the presentation, we'll have about 5 minutes to answer your questions. You don't need to turn on the microphone on your computer. And also, another thing is that don't wait until the last minute to post your question. If you have any question during our presentation, please always feel free to post that, and we'll get back to you. Yeah. Okay, now let's get started. First, a brief introduction of our program. The Lemelson-MIT Program is a multifaceted program for inventors at all ages. We have specifically 3 grant initiatives working with high school and middle school teachers and students. That is the Inventive Grant Initiative and the JV Inventives Grant Initiative. Our Inventive Grant Initiative is already 15 years old. Our high school invent teams have received 7 US patents, and a lot of them are in the process of applying for them. And lots of our students have presented at local or state level or national conferences or design all this kind of maker conventions. And for our JV Inventive Grant Initiative, we mainly support middle school and early high school teachers and students. And we provide free materials and staff support and also the curriculum. If you are interested in either of our grants initiative, please feel free to contact us for more information. So this evening, I'm very happy to invite 2 of our master teachers to share their experience. They are Mike Gallagher and Doug Scott. They're going to talk to us about how they support how their students use 3D printing during the invention projects. A little bit introduction of Mike. Mike is a technology teacher at Saratoga Springs High School in New York. He leads the technology education department at his school, and he's an experienced project leader teacher. Approximately 10 years ago, Mike led the Saratoga Springs High School invent team, and they invented the Garden Consultant. So the Garden Consultant is actually an automatic system that kind of use sensors to collect the different data about the soil, and then it will automatically analyze this data and compare with the database from the U.S. Department of Agriculture. And the purpose is to find the optimal plants to grow in this kind of a soil. I just wish that this can be used largely in farming, so that we can potentially grow lots of plants at their best conditions. Okay. And next, a little bit of introduction of Doug. Doug is a robotics and engineering teacher working at Hopkinton High School, and he's the STEM Teacher of the Year in Massachusetts in 2014. In 2013, Doug, at that time, he was working at the Natick High School. He led the Natick High School invent teams, and they together invented a great device to help find the potential survivors in icy water. This is going to be very important, especially for the winter time. If you especially think about this morning in Boston, we're still snowing, how important it is for the search and rescue team. They can have this kind of device find those potential survivors in icy lake. And in 2016, Doug and his teams, they were awarded a patent for their invention. Okay. So Doug and Scott, thanks a lot for leading the students in this fantastic invention projects, and welcome you both to our webinar this evening. Okay. Before we dive too deeply into 3D printing, I just want to briefly talk about why we need to think about 3D printing in invention and why it is important to support students. 3D printing can support the invention projects. First, our group, as a lot of you might have known, that we focus on technical invention. We feel that an invention needs to be useful. That means it needs to be useful for certain people, certain users or consumers, and it needs to be unique. That means it needs to be new, or it needs to be something that was not previously known. And also it needs to be reduced to practice. That means kids or people can use the idea and create a prototype so that it can prove this kind of idea. Our pre-experience found that students typically go through this 4 iterative processes during invention, like finding problems, inquiry, doing research, and then designing and building and testing phases. And specifically for 3D printing, we observed a lot of high school students or even middle school students and teachers. They very frequently use 3D printing during the 3 phases here: the inquiry and research phase, the design phase, and also the building and testing phase. For example, when students were at the very early stage, they have lots of invention ideas and they were trying to select which might be the promising direction. This is the time students can quickly use 3D printing to print out some prototype solutions. And then this will help give students a quick sense about, well, this direction kind of work? Should they continue pursuing this direction, or maybe this direction doesn't work at all? They should go through the other ideas. So the students using 3D printing in this kind of phases, all this would enable students to quickly materialize their ideas, and also in a fast and also affordable ways. This would also together will speed up the invention processes, and students instead wouldn't waste too much time trying to figure out what might be the material or what might be the right way they try to assemble all the different parts just for prototyping. 3D printing process, it would be very much helpful, especially when students were doing prototyping testing phase. Okay. So next, we just talk about how the benefits of 3D printing in invention. But exactly what is 3D printing? What happens when we try to 3D print something? So here, first, the 3D printing is a type of additive fabrication process. That means, when we try to create an object through 3D printing, the printer actually what the printer does was it lays down successive layers of materials until it kind of becomes this kind of pre-designed shape that students design using CAD tools. You can imagine each of these layers as one of those thinly sliced horizontal cross-section of the final products. And this whole process is the 3D printing keep laying down all these layers together until it finally becomes the final product students want to have. And this process is opposite to the subtractive fabrication process. That is the process of making an object by trying to cutting out or hollowing out a piece of metal or plastic with machines or tools. You can, for example, if you have students work with woods or as a carpenter, you can see that this kind of subtractive fabrication process is often used there. And as we mentioned before, the benefits of 3D printing include that it's fast and it's cheap, it's relatively affordable for most schools, and also it can save a lot of materials than using the traditional manufacturing materials. Now, And also importantly, it's a lot of fun. Often you will find students who will stare at the 3D printing for a long time and they love to play with that. Yeah, here are just the pictures of Mike's students' work. Mike, can you tell us more about what are those?
So one of the projects I came up with for our introductory to solid modeling course was to have the students make a chess set. They worked in groups. They came up with some type of a theme, um, and then I found it worked well to have these pieces because they're not too expensive. One of the things we'll get into later is the cost of materials, and this is something where the kids can all walk away with these pieces. And in fact, I get the we pick the best in the class, and that group ends up walking away with a whole set of pieces. So
Mhm. Oh, they must be very proud of this.
yeah, that's one of the projects the students get really excited about, as opposed to just printing on paper. I mean, it looks nice, but to actually walk away with a physical device, it's a nice project.
Hmm. Great. Yeah, Doug, I know your students also did great work on this. Can you tell us about their project?
Sure. We have a project that we do where we have students, again, like Mike, to learn solid modeling. We use Autodesk Fusion 360, and the students have to learn that program. And a nice way to do it is to design some simple designs, and we have them come up with a unique uh, rendition or alteration to a Altoids tin. So this student, she chose to create an organizer. And for us, 3D printing, it does take time and it does cost. So we still require the students to come up with a rapid prototype. In this case, in the top left, you'll see clay. So the student modeled it in clay. Then she designed it in CAD, which is below. And then on the right is her final product, which was printed out and assembled and put on display. She had created a office supply organizer. So a nice way for each individual student to do something that's relatively quick. So like Mike, this is a fast way to get kids introduced to 3D modeling and printing.
Hmm. Yeah. Your students also did more fascinating work. Can you talk more about that?
Yeah, I mean, you can go in a lot of different directions with modeling and printing. On the left-hand side, we have a student that did a 3D competition. So the student had to produce a locomotive, and so what the student did was create his his train, and he had to create half of it because in most of the slicing software that's part of 3D printing, you can mirror things. So he printed half, mirrored it, and then glued the two sides together, took the assembly and did some pick work and cleaning work on it, uh, primed it, sanded it, and painted it with multiple coats, and presented his work. On the right-hand side, you'll see we do a hydropower wheel in our sustainable class, and the students have to generate electricity. In the second half of that, they actually create a saw assembly, and they saw um, pretzel sticks because we can't cut wood with what we make, but they'll create like a linear saw blade that runs on a cam system. And but this wheel here, the students compete to see how much power they can put out with their wheels.
Wow. These are amazing projects. I see how students are engaging in this. Yeah, it's amazing. Okay, so next before, yeah, thanks a lot, Mike and Doug, for sharing all these exciting ideas. Yeah, next before we start talking more about the 3D printing or working with 3D printing or setting it up in the classrooms, I just want to emphasize the basic safety rules. As any kind of tools we're using in classrooms, always you need to make sure that students need to have a plan about what you are going to do and make sure you secure the workplace and make sure students, if they are not sure about how to work with the tool, they can always ask about it. And the most important thing also is try to clean up the whole workplace. So it's always try to emphasize all the safety rules before having students work with the 3D printers. Next, we are going to start talking about the 3D printers. I will specifically ask Doug and Mike to talk about their experience. Here we have different recommendations based on what kind of budget you have about the different 3D printers. So first, I guess I will have Doug start. Doug, I know you use all these amazing, relatively cheap 3D printers, but they work really well in your class. Can you talk about them?
Sure. Uh, I'm very cheap, and
Yeah.
and we do things as cheap as possible that work. Um, there are higher end machines that you can use, but one of the things that I found was I really didn't want the students printing large objects because it takes a lot of material and takes a lot of time. So we try to scale things down a little bit. So as a result, the small machine on the left has about a 5 by 5 by 5 printing volume. So just imagine a cube that's a 5-inch cube, and that's about the size that you could print out on that machine. This is the white machine on the left with a little cat on it. And it's made by Monoprice. It costs around $200. Sometimes you can get them on sale for $180 with free shipping. And there's one thing that I was telling Helen and Mike earlier that is a hitch with this machine. After about 4 months, it's known to have one of the wires that heats the bed. One of the wires will break because of the movement of the way that it's set up. And there's an easy fix for that, a little soldering job that takes about 10 minutes. So for $200, I'm willing to put in 10 minutes of soldering about 4 months after buying, and that works fine. And I've been able to put a bank of these together in the room. And then we have one of the large ones on the right. I actually bought the one on the right for $275 on an open box. Sometimes I'll watch for an open box and make sure that it's nothing catastrophic that's wrong with the machine and make sure that it's under warranty. And I took a chance on an open box, and it's worked great for $275. So for $75 more, we were able to get an 8x8 printer, which prints everything as large as we would need in our shop. So those are the two machines that we use in our shop.
Yeah. Great. Yeah.
I have
So
a question
next,
for you, Doug. Doug, can they
Sure.
print in both PLA and ABS?
They are rated for both, but I've chosen to use one thing about, as the instructor in the room, one, the PLA doesn't give off the gases that the ABS will, so I like the PLA. The PLA is a starch base, so it's like a corn or a sugar starch based material with the polylactic acid. And the printers here, you'll see they don't have any enclosures or exhaust systems. So when I used to print in ABS, you'd fill the room with a stink of plastic, which I didn't think was healthy for anyone. So I chose to go with the PLA. And to be honest with you, I have found through the vendor that I buy from, the PLA filament prints best. And I've even made it more finite where the translucent colored ones that I buy, so if I buy like translucent orange, it will print better than solid orange PLA. So I found that those translucent PLA colors print beautifully. And if we need to, like that kid with the train, he wanted to paint his gold, we just painted it. That was fine.
Yeah.
That's great. Yeah. Thank you very much, Doug, for talking about your printers. Yeah. So next, Micah, can you talk? I know you have these printers in your classroom. Can you talk about your experience of this?
Yeah, so first I'll go with the LulzBot, the TAS 5. That's the one that I recommend. I've got 4 of them right now, and they virtually run 24/7. They're constantly going. In fact, it's at this point in my department, because we're at the end of the year, all the kids are able to design stuff. They walk in the door, and it's like, who gets there first to get things rolling on there? It uses the open source platform. It runs on Cura, so you can kind of customize everything, make it run the way you like. But with that said, it's maybe not the best for like a makerspace where it's not like a plug and play. That's where the Affinia comes into play. So that is more designed for your everybody. Not too much to mess around with that one. I personally prefer the Lulzbot, but if you're one you want to have a fully enclosed one, it now heats up inside, and that one I would say would be a better one if you want to go the route of ABS. But I'm with Doug. I find with the student projects, PLA works fine almost all the time. The next one, the Dremel, I have seen that. I don't own that one. So I've seen it in place. A lot of people speak very highly of it. It's really well reviewed. In fact, a little bit better reviewed than the Affinia. But I can't say that I've actually used it myself.
Mhm. Okay, great. Yes. Okay. So next one is the whole set. Thank you so much for that. You know, the previous page, all the printers will cost about less than $2,000. Now we're kind of moving more into the high end of the 3D printers. Mike, do you use Ultimator Maker in
Yes,
your
so
classroom?
the new Ultimaker and comes with a dual head extruder. So as Doug was talking about his student's project where he had to do a lot of pick work, he called it, uh, it's removing support material. So if you make a part that has like an overhang on it, you have to build material up so it doesn't fall back to the bed. And when you're doing that, and you have one type of material that's coming out of it, you have to break that material away later on. And the process of breaking it away can do damage to the part and take a lot of time. And it affects the resolution on the part, obviously. So Ultimaker came up with a relatively cheap version of a soluble support material. So you could just put this in water. What you can see, if you point here into the bed there, Helen, you can see that white stuff where it's being printed out. That's actually support material. So when this print is done, they'll pull that thing out and then put it in a bath of water, and it'll just dissolve away. So if you see that thing in the lower left-hand corner, that little gear inside of a gear, that was that. That's what was made on that machine.
Mm-hmm.
So if you were to make that with a traditional fused deposition modeler, which is the ones that we've been talking about so far, um, it would be really difficult to go in and break away all those supports on the inside. So they picked that part for a reason because it lends itself to a dual head and something that you can dissolve those supports.
Mm-hmm.
Next, I have two of the Formlab 2s, and that uses a completely different technology. It's a stereolithography printer, and as opposed to fusing melted plastic together, similar to like a hot glue gun, this one uses a bed of photoreactive resin, and um, there's a laser underneath it that fires into that bed of photoreactive resin, and then a tray pulls that material up, and it's built from the bottom up. It draws the material in, and in the back, which you can't really see there, there's a cartridge just full of that photoreactive resin, and it draws it up, and that makes a fantastic part. They're really unbelievable, the quality of it. I mean, absolutely amazing. But also the material is extremely expensive. The resins are, if you get them on the floor, and I've done that on a regular basis, it's not the best. Sticky stuff. And you have to be cautious when you're handling it. So this one, I certainly don't let the students mess around with it myself. I do all the stuff. When the students print on that one, that's more of like the final run on stuff. We don't do like everybody's chest pieces and that kind of stuff on there. Next, the Hyro. This was given to me by a friend. I actually wouldn't have bought this one, but it's capable. The design of this one was one where you could switch out the head types and do a whole variety of printing. And my friend got it for me. He wanted to do some printing in porcelain, and so I've done a little bit of porcelain printing, which is just really cool stuff. So he gave it to donated to our school when he was done with the projects that he wanted to do. So kind of a cool thing, and we can do, but I wouldn't recommend it.
Mhm. Thanks a lot, Mike, for the review. Yeah, so next thing you know, we have students work with the 3D printers, and also it's important students work with all the CAD tools so that they can have a plan before they start working with the 3D printing. Yeah, so Mike, can you talk about the CAD tools your students use and
Yep.
yeah, give us
Okay, so
recommendations?
we actually have we now do some of the STEM classes at the elementary level, and we have them using Tinkercad, and they're starting that in second grade, and the kids the kids actually love it. They work with primitive shapes in there, so they start off with if you wanted to draw a ball, we just have balls that are pre-made. They drop them into space. And if they wanted to make a square, they're squares, and they can make them smaller or bigger. They can use them for additive or subtractive. And the kids really get into that, and they don't actually mind working with that all the way up into the middle school. Um, After that, I'm going to kind of jump around here, but we teach Autodesk Inventor. So prior to that, I had learned in AutoCAD. So AutoCAD is more designed as a 2D, more of an old school engineering program, but obviously it's capable of making things in 3D that could be 3D printed, but much more difficult. It was designed for 2D things. So uh, Autodesk, back in the late 90s, um, made a big investment to go 3D and made a brand new program, and they made Autodesk Inventor. So that's where we currently are, and that program resides on the computer, designed for single users, and they can share part files around. In fact, Autodesk has a thing called the Volt, designed to share files, but can't. So if you think of that as being like Microsoft Word, on your computer, and then something like Google Docs comes out where multiple users can simultaneously work on files. That was the advent of Fusion 360. So that was released a couple years ago, and Fusion 360 is all cloud based. So, like Google Docs, multiple users can be simultaneously editing files, um, and working in different locations where you couldn't do that with Autodesk Inventor. Now, SolidWorks is the competitor to Autodesk Inventor, and they saw the handwriting on the wall that kind of everything was going to be moving to the cloud as well, and they made Onshape. So Onshape is now pictured in the lower right-hand corner, and you could work in that on your Mac. You could use it on your Windows. You could use it on your phone. I have it on my phone, and you can use it on your iPad. Same thing with Fusion 360. They make these programs now where you don't have to have a super powerful computer. It's all done in the cloud. And the last one there is SketchUp, which used to be Google SketchUp, but they get rid of it. That's open source. People are making a ton of stuff, and that's another one that the kids really love to get in and play around with in one of these open source communities where there's tons of things out there the kids can just grab up, but not really a particularly high-end solid modeling program like all the other ones that we listed.
That's great. Yeah. So next, we just talk about all the tools, the 3D printers, the using having students work with computers. Now I want Doug and Mike, can you talk us about how do you set up 3D printers in your classroom? How do you manage with all the materials, all this? Yeah, Doug, let's start from you. The picture here is a picture from your classroom. Can you talk about how you set it up?
Yeah, we have a relatively small space, so what we're trying to do here is keep it as small as possible and as uh, mobile as possible. In the summertime, I like to put all the equipment away. So having all the 3D printers on this mobile rack works well. Um, I wait till they're on sale. I can get that rack at BJ's for $80. Typically 100, but they sell them twice a year for $20 off. So for 80 bucks, I can get a wire rack. I don't like uh, the printers. A lot of them come with side feeds. I like the printers to feed from overhead, so you'll see the spools above the machines that we're using. The filament we'll take the filament. I shared earlier on the chat the link for Gizmo Dorks. That's where I buy the PLA from. And you'll see the white buckets down below. When we're not using the PLA, we store the filament in a sealed container. Otherwise, it will degrade. It'll become very brittle. Always budget ahead for the purchasing of filament. If you have students that want to do private print work, what I usually will do is say, that's fine. Let's figure out how much material you use, and the Cura software that Mike uses, we also use, and that will tell us how much the machine will use for material, a fair estimate. And I'll say to the student, well, it takes X amount of grams, so it's going to cost you, $4 in material if you want to print your own fun little project that you bring in the side, because you will have a lot of students approach you. And if the student really wants it, they'll do it. If not, they won't. And then again, you do need at least 2 printers, because if something goes wrong, you're going to need a backup. And then what I found is I need, we now have 9 machines. In this we had 7 total, but now we're up to 9. And it takes a long time to print, so you want multiple machines. You can start out with a couple, but in time you'll probably get more.
Great, yeah. Thank you. Yeah. So now let's move on to Mike's classroom. Yeah, Mike, can you talk about how you set it up and then all this?
So I always feel like Doug's just copying me. I set this up long before him.
Yeah. Mike sent me yeah. I took pictures, yeah.
So very similar setup. Mine's just bigger and more expensive. That's all. So the same exact thing. One of the things you realize when you get one of these 3D printers is it's awesome, but we all teach classes with 25 students in them, and most of these things you're printing are going to take multiple hours to do, and you're going to have print failures. So to really do it, you have to be aware that you really should plan on getting a couple of these printers. And as you see my big stack of filament down there, it takes a lot of filament. If you have several sections of these things, and every kid walking away with one little thing adds up pretty quick. I have a teacher load in my school is 250 students per teacher, and it goes fast. So what I suggest is put them in a place that is well protected. The kids just like to come up and touch it, and they want to get their hand on it, look at it, or even just get distracted and watch it. It's like, we all like to watch the microwave cook our popcorn, one of their inventions coming to life on a 3D printer, it's hard to take your eyes away from it. So this is actually my office, and once I put these in the office, I found that it's amazing how much more effective they are. Bring the kids in, let them take a look at it, and then leave it alone. Let it do its job. Come back at the end of the day, and it'll be done.
Mm-hmm.
Yep. I'm going to add to that just one tip I threw out there on the chat was, if you can set up, I have an old laptop that I leave on our cart. If you go back, Helen, for 1 sec, and the laptop up at the top, you'll see a monitor. I have one computer there, and I leave it logged into an email account that is 3D print at our address, and the kids send the files to that email address, and it sets up a queue. So when the kids come over, there's no question about who's next in line to print, and they can download the file and do all their work right there and set up the print, and then they walk away, and then the next kid comes in.
Mm-hmm. Yeah, that's a great tip. Yeah. Mike, I also know that, you have a set of tools, when students are working with you, especially with so many kids, it's important. Can you tell us about that tools you have there?
Yeah, that's one of the things I collected over time. You find that there's, like the nozzles might get clogged or whatever. I have a couple bags there hanging with some things like that. The trim out tools are for picking, goes in there, a wrench, a couple other little things that I just find we use on a regular basis. And then what you can't really see is I also have a little bucket where they put the breakaways, any extra stuff, we throw it in there. And it seems to work well, because if you don't have it, then the stuff gets lost pretty quick.
Yeah. Great. Yeah. Thank you so much for sharing all these real great tips and suggestions. Yeah, here I just want to wrap up a little bit, as we talk about that 3D printing is a powerful tool for prototyping invention solutions. But as a teacher, you need to be aware at, the printers and the materials and as well the maintenance costs are relatively expensive. So this is just one suggestion we have is, as we see that a lot of schools, especially if your school is in the urban area, that you might have difficulties having your own 3D printers in your classroom. So please be always proactive in seeking help from your communities. Sometimes you might find that your local libraries or community centers or local businesses offer some 3D printing services that's relatively easy and more affordable, and then you can always send your students work, make sure it's the final work that they can have it printed out, and then you don't need to deal with the cost of the printing, the cost of the printers and the maintenance and the materials all in your schools. Okay, so here I just want to quickly go through the resources. As we said, these are the resources we have online. It's about our event teams, JV event teams, grant initiatives. And here are just some resources about reviews of different 3D printers. And also now 3D printed shoes is becoming a new trend in the shoe business. So this is a review from I believe it's from New York Times, talking about how Nike, Adidas, and all these kind of top footwear companies are using 3D printing in shoes. And we also have a book that we recommend if you are working with 3D printers, all the CAD tools, you can always read about it. Yeah, I know it's already 7 minutes over 7. So if you have any questions, please feel free to put in the chat window. Doug and Mike can help answer those. I know, Doug, you have been answering questions. Yeah, so if you have any more questions, please just put it there. Yeah. Okay. I was just going through the question. Yeah. So, okay. Logan has the question. Which CAD websites are free and don't require cloud?
When I said cloud, you don't have to set up like a cloud server. They do it for you, but the Fusion 360 is free, and also Inventor's free as well. And Onshape is free, um, but you don't get any encryption. And if you're a teacher or a student, you probably don't care about that. But what their model is they do it kind of like the App Store, where they have their own App Store. And if you want to do things like, let's say, stress strain analysis, um, some finite element analysis, maybe some high end video stuff, you pay for those extra high end things. But Fusion 360 is free for kids. Autodesk Inventor, free for kids. And Onshape for the most part is free for kids, and SketchUp is free. If I were to start today, I would go with Fusion 360, but I don't do it. I do Inventor. Doug's a 360 guy.
Okay. Yeah, so if you have any other questions, please post it on the chat window. Yeah. And also, if you after this, maybe like after this webinar, you will realize, yeah, I have some questions. Please always just email us. We have our contact information here at pd-lemelson@mit.edu, and we're more than happy to set up a conversation with you, or we can always help you point you to the right person, like master teachers like Mike and Doug. They can give you more practical suggestions on your questions.